Welcome on Vandana Classes YouTube channel. I am Mishra with you to discuss important questions regarding trigonometry. Hope you will enjoy this session. My dear student, in this question it has been given that tan theta is equal to 1 upon root 7 and you need to show that cosec square theta minus sec square theta upon cosec square theta plus sec square theta is equal to 3 upon 4. To solve this question, you need to consider a right angle triangle. I have just considered a right angle triangle ABC in which angle B is equal to 90 degree and angle C is equal to theta. Then tan theta is equal to, you know that, perpendicular upon base, and in this right angle triangle AB is perpendicular and BC is base, and this is why it can be written as AB upon BC, which is equal to 1 upon root 7. Again let AB is equal to K and BC is equal to root 7K. Then you have to apply the Pythagoras theorem, and by Pythagoras theorem AC square is equal to AB square plus BC square. Putting the value of AB and BC, you can get K square plus root 7K whole square, and which is equal to K square plus 7K square. K square plus 7K square is equal to 8K square, and this is why AC is equal to square root under 8K square is equal to root 8K, and this is why the value of AC is root 8K. And now cosec theta is equal to, that you know that cosec theta is equal to hypotenuse upon perpendicular. This is why it can be written as AC upon AB, and the value of AC just find out root 8K and AB is K, so it can be written as root 8. And sec theta is equal to, that you know that, perpendicular upon base. Perpendicular in this figure is AC and base is BC, so AC upon BC is equal to root 8K upon root 7K, and in simplest form it can be written as root 8 upon square root 7. Now the value of cosec theta and sec theta you have to put in the LHS portion of the identity that has been given, and in this question LHS portion is cosec square theta minus sec square theta upon cosec square theta plus sec square theta, putting the value of cosec theta and sec theta, and on simplification you can get 3 upon 4. That is the RHS portion, RHS of this question. In this question you can just see that if sin theta is equal to A upon B, you need to prove that sec theta plus tan theta is equal to square root under B plus A upon B minus A. This is the question. You need to consider a right angle triangle, and I have just considered a right angle triangle ABC in which angle B is equal to 90 degree and angle C is theta. In this question sin theta is equal to, sin theta, that you know that, perpendicular upon hypotenuse. Perpendicular in this figure is AB and hypotenuse is AC, so sin theta is equal to AB upon AC, which is equal to, according to question, A upon B, and this is why we have just considered AB is equal to A and AC is equal to B. After that you have to apply the Pythagoras theorem, and by Pythagoras theorem you know very well that BC square is equal to AC square minus AB square, and the value of AC is B, so it can be written as B square minus the value of AB is A, so AB square can be written as A square. BC is equal to square root under B square minus A square. After that you need to put the value in place of sec theta and tan theta. Sec theta is equal to hypotenuse upon base, so sec theta is equal to AC upon BC, which is equal to B upon square root under B square minus A square, and tan theta is equal to perpendicular upon base, so it can be written as AB upon BC, which is equal to A upon square root under B square minus A square. After that LHS part of the question is sec theta plus tan theta, you have to put the value of sec theta, that is b upon square root under b square minus a square, and the value of tan theta is a upon square root under b square minus a square. After that, the LHS of denominator is square root under b square minus a square, and numerator on simplification it can be written as b plus a. Now you have to just pay attention that 2 can be written as root 2 whole square. Write down b plus a can be written as square root under b plus a whole square, and since it has been, and b square minus a square can be written as b plus a into b minus a by using the identities m square minus n square is equal to m plus n into m minus n. And after that, since it is whole square, so you can write down it 2 times, and square root under, you know very well that square root under mn can be written as square root under m into square root under n. You have to apply the same result in this case. Square root under b plus a into b minus a can be written as square root under b plus a into square root under b minus a. Now square root under b plus a and upon square root under b plus a both are cancelled, and what you get, square root under b plus a upon square root under b minus a. Again you have to apply the properties. Square root under m upon square root under n can be written as square root under m upon n. By applying the same properties, you can just write down square root under b plus a upon square root under b minus a as square root under b plus a b minus a. That is the RHS part of this question. My dear student, in this question you can just see that if tan theta is equal to a upon b, you need to prove a sin theta minus b cos theta upon a sin theta plus b cos theta is equal to a square minus b square upon a square plus b square. In this question, for the solution purposes, you need to consider a right angle triangle. ABC I have just considered it, and angle B I have just considered a right angle triangle in which angle B is equal to 90 degree and angle C is equal to theta. Tan theta is equal to perpendicular upon base. So in this triangle, tan theta is equal to AB upon BC, which is equal to A upon B. Again let AB is equal to A and BC is equal to B. So perpendicular is A and base is B in this triangle. And after that, we have to apply Pythagoras theorem, and by Pythagoras theorem AC square is equal to AB square plus BC square, which is equal to A square plus B square, and therefore AC is equal to square root under A square plus B square. Now sin theta is equal to AB upon AC, because you know that sin theta is equal to perpendicular upon hypotenuse, and this is why sin theta is equal to AB upon AC, which is equal to A upon square root under A square plus B square. And cos theta, that you know that base upon hypotenuse, and this is why it is equal to BC upon AC, which is equal to B upon square root under A square plus B square. Now you can just check the LHS portion of this question, and you have to put the value of sin theta and cos theta in its LHS portion, and that is A sin theta minus B cos theta upon A sin theta plus B cos theta. And you need to put the value of sin theta and cos theta in this figure, and by putting the value you can get A into A upon root under A square plus B square, because sin theta is equal to square root under A square plus B square. And what is the value of cos theta? Cos theta you need to put here B into B upon square root under A square plus B square upon A into a upon square root under a square plus b square plus b into b upon square root under a square plus b square. You have just put the value, and after that you know that a into a square, so a square upon square root under a square plus b square, b into b square, so b square upon square root under a square plus b square. Similarly you have to do in the denominator a square upon square root under a square plus b square upon square root under a square plus b square. Now on the simplification you can just write down a square minus b square upon square root under a square plus b square upon, and on simplification of the denominator this converts as a square plus b square upon square root under a square plus b square. Here square root under a square plus b square and square root under a square plus b square both are cancelled because both are present in the denominator of the numerator and its denominator parts, and this is why it is equal to a square minus b square upon a square plus b square. That is the RHS of this trigonometric identity. So that is the proof of this question. Thanks for watching Vandana Classes YouTube channel. Please like, share and comment. You get the benefit by watching this video. If you have any sort of problem, then you must write down in the comment box, or you can send or inform through WhatsApp number